Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our Python series, and the question we have this time is quicksort. Okay, it is from the time and complexity module. So let us see that what is quicksort and what we are going to do with the help of this quicksort. So first of all, quicksort is a sorting algorithm. Quicksort is a sorting algorithm, and we are going to sort an array using this quicksort. Okay, we are going to use it for sorting an array. Okay, so let us see that how we are going to use this. So first of all, quicksort is dependent or based, we can say. Quicksort is based on partitioning. Okay, we are going to use partitioning in this. So if you have not watched the video of partitioning of an array yet, so I request you to kindly watch that video first so that you can understand this question better. Okay, so let us start that what we are going to do in quicksort. Okay, we know that what we have to do, we have to just sort an array. Okay, and how? Using quicksort. So let us see how we are going to do this quicksort. So for this, let us take an array. First of all, let us say we have 5 4 0 1 1 2 and 3, right? We have this. It is nearly sorted. So let's take some another example. It will be 5, then 4 6 3 1 2. Okay, this will be good. So let us see that what we do in partitioning. So in partitioning, what we used to do is we have a pivot. Around that pivot, we used to do partitioning. So what happens when we do partitioning? When we do partitioning of an array, then after that, the pivot that we have, what happens with it is all the elements that are greater than this pivot comes to the right of this pivot, and all the elements that are smaller or equal to this pivot comes on the left of this pivot. Okay, so let me show you what happens if I do partitioning here. So if I do partitioning here, then 2 is here. Okay, 2 is the pivot here. Then the elements that are greater than 2, that means 5 4 6 3 will come on its right, and 1 will come on its left. Okay, so this is what happens when we do partitioning of an array. Okay, so we take a pivot, we partition the array around that pivot, and after partitioning, all the elements that are greater than that pivot comes to its right, and the smaller element or the equal element comes to its left. Okay, this is what happens in partitioning. So how we are going to use it? Suppose, have you observed that when we do partition, then at that time what happens is the pivot, our pivot comes to its sorted position. Have you observed this? See, suppose if this array is sorted, then how it will be? It would be like 1 2 3 4 5 6, right? It would be like this. So what would be the position of 2 in the sorted array? In the sorted array, it would be in the first index. And where is it in this time? This time also it is in the first index. Okay, so this is why I'm saying that when we do partitioning, the element, that means pivot element, the pivot elements comes to its sorted position. Okay, this is what we have to observe, and this is how we are going to use this in quicksort. So what will happen is, suppose I have 2 in the sorted position, right? 2 is already sorted. Now no need to work with this 2. Okay, with this pivot we don't need to do any work. So what we are going to do, suppose if the right side will sort itself and the left side will sort itself, will this array will be sorted then? Yes, it will be. Okay, suppose somehow this side will sort itself. That means it will become like 3 4 5 and 6, and this will be 1. It is already sorted. Okay, so if it is sorted itself in this manner, and 1 is already sorted and 2 is already sorted, so then this whole array will be sorted, right? So this is what we are going to do. So how we are going to do, let us see. So in this case, partition that we are going to apply, okay, that partition that we are going to apply will return me a partitioning index, and with the help of this partitioning index, I'm going to do this left side sort and right side sort. Okay, left side sort and right side sort I'm going to do with the help of this partitioning index. Okay, so how it will be, see, 2 is already sorted, right? So with the help, so in this case, what we are going to do, we'll say go and sort yourself by taking a pivot. Okay, but we will say go and sort yourself by taking a pivot. We'll say it that go and sort the left side by taking a pivot. Okay, and then that pivot will do the work. So my faith is here I'm going to use the recursion. You can see that, right? How? Because my work will be done by a faith. My work will be done by a faith. So what my faith is that I'll take a pivot, and that pivot will sort itself, and then I'll say the right side of the pivot and the left side of the pivot to sort themselves, and then my whole array will be sorted. With the help of this faith. Okay, this is how I'm reaching to my expectation from faith. Expectation to, first of all, I have my faith, and with the help of that faith, I'm reaching the expectation that my array will be sorted. Okay, my array will be sorted. So this is what is happening here. Okay, so let us see that how we are going to sort this. Let me show you the dry run. After that we will be writing the code for the same. So we have this, right? We have this. So what will be done now? In this array, 2 is in the sorted position, right? 2 is in the sorted position, so call for its left end. That means call for the 1, take its pivot. Then take this array 3, 5, 4, 6, 3, and take 3 as the pivot and sort it. Okay, it will go and first of all it will arrange at 3 at its right position. So 3 at its right position means where will be the 3 at this time? 3 will be in the first index, and then 5, 4, 6 will be there. 3 and then 5, 4, 6. 3 and then 5, 4 and 6. So now it will call to its right and left. So now call its right. Its left will be nothing, right? There is no element in the left, so left will be an empty call, and the right will be 5, 4, 6, and 6 will be the pivot this time. So 6 will adjust itself. 6 in the right position, so it will call itself from there. From there only it will call itself. So how it would be like? 6 will call itself, right? 6 will do a left call and a right call. Right call will be empty and left call will be 5 and 4. 4 will be pivot this time. Okay, 4 will be pivot this time. 1 is sorted here. No need to call again because one element is sorted. One element in the array is already sorted, right? We don't need to go to 0 element, right? One element is already sorted, so we can leave it here. No need to call further. So now we have 4, 5. So 4, 5, 4 will adjust itself. So how 4 will adjust itself? 4 will say that it will be like 4, 5, and this is pivot. So this will call empty. This will call 5. 5 is already sorted. 5 is already sorted. So now we have this. Okay, this change. See, we have not made any array, right? We have not made any array this time. What we have did is we just have passed an index. We just have passed a range that sort the same array from this range to this range. We passed a range that, suppose we have PIDX here, right? We passed PIDX plus 1 to the last index, and we said go and sort this side, and we pass 0 to this PIDX minus 1. Okay, and we said go and sort this one. So it sorted PIDX minus 1, it sorted this one. So this is how this whole array will be sorted. Okay, so let us see now what changes will occur in the original array. How the changes are going to be occur in the original array. So how it will be like 4 and 5 is here, right? So the change will occur to this first, right? 4 and 5 will place itself to like this. So this change is there, right? So 456 it was this, right? So it will arrange itself like this, 456, then this will return, this will return, this will return itself, this will make itself like this, and here it will return this, and then 4 3 4 5 6, right? So 3 4 5 6, this side came back by becoming 3 4 5 6, right? This side came back by becoming 3 4 5 6, and one came back by becoming this only. So my whole array is sorted now. As you can see, we have 1 2 3 4 5 6, which is a sorted array. Okay, so this is how my array is sorted. So let me write a code for the same. It is quite easy question. It is an easy question. So how we are going to do this? First of all, what we need pivot. First of all, we need pivot because we need to sort, we need to do partition around that pivot. So let us take this pivot. Okay, pivot is equals to array at high, right? Array at high. Last index is my pivot. You can take any index as any element as a pivot, but I'm taking the last element as a pivot. So let us, after that, what we are going to do is we are going to do a partition around that pivot. So partition will return me a partition index. That is why I'm writing this PIDX equal to partition. This partition will be given to you in the snippet only. Okay, you don't have to write this partition again. You just have to complete this quick sort function. So partition will take array, it will take pivot, it will take my low and high. Okay, these four things it will take, and it will return me a partitioning index. And around that partitioning index, what I need to do is I need to apply my recursion. My faith is that this PIDX it is at its right position. Okay, so don't need to sort it, it is already sorted. Sort the left side of it, sort the right side of it. So for the left side, what I'll do is I will call IRR from low to PIDX minus 1, right? For the left side. And for the right side, what I'll do is quick sort ARR, and here it is right side, right? So right side will start from PIDX plus 1 and it will go till high. So this is it. So is it enough? Let us see again. Is it enough? We are using recursion, right? So recursion, where will it stop? We need to figure out that. Base case. So let us see. So here, what we have is, here we have only one element, we return from that, right? When one element means when low and high both are at the same point. That means we have only one element, right? So this is our base case, right? When low is equals to high. So and also one more thing, we have these means we have these low greater than high conditions, right? In this condition, low came to greater than high, so this is also our base case. So our base case will be, we have to stop it if okay, here I'm writing this semicolon because I used to do this. Okay, if you don't want to write this semicolon, then you can leave it because it is not necessary in Python. Okay, so what we are going to do is base case, right? When low is greater than high, greater than equal to high, at that condition we were stopping it, right? So when low is greater than high, at that condition, what we will do, we will simply return it, right? It is not returning anything, right? And the return type is void. I mean a void in this Python. Okay, void in the Python. We just changing in the array. And here we need to understand that we are passing a range from which it is sorting. We are not taking any extra space. We are not making any array. We just passing the range which is changing itself to in the original array. Okay, so this is how the original array will change itself. So let us give it a run. Will it run or not? Let us see. Okay, it is giving us a wrong answer. So let us see why. Suppose, first of all, see this. This is the output that I have. This is the array that I have. So the array that I have, if you can observe this, -2 1 3 4 7, it is sorted. What the target was to sort an array, right? using quicksort. We used quicksort, we sorted an array, it is a sorted array. It is a sorted array. And for every case, it will sort every array, okay? It will sort every array that you will pass. But why this code is not running? For passing this in our portal, what we have did is, we have not stopped our base case here. And, but we have reached to this step. Which step? To this one, where we are calling low greater than high only, okay? Not as low greater than, not at low greater than equal to high, but we have reached to low greater than high only, okay? We just have stopped here, not at equal to condition, but at greater than condition, okay? So this is what the only change you have to do if you want this question to be accepted. So let us give it a run again. So it is accepted this time. Let us give it as final submit. So the code is completely submitted. So I hope that you got this quicksort algorithm, okay? And after this, we'll meet in the next video. So till then, goodbye, take care, and also do not do not forget to like and subscribe our channel. Goodbye, take care.